In our fifth video, we're addressing the influence of the substrate and what other parameters are to be observed. In a nutshell, the surfaces should be as smooth as possible and highly energetic. Now, what does that mean? The surface roughness of the substrate determines the flowability required by the pressure-sensitive adhesive, or PSA for short. For rough surfaces, softer and thicker PSAs have to be used. For very smooth surfaces, less flowable and thinner PSAs can be used. The surface energy affects the ability of the adhesive to spread across the substrate and to fully coat it. Consequently, coordinating the surface energy and the adhesive is decisive for adhesion. Good adhesion is achieved on highly energetic plastics such as PC and ABS, as well as on metal and glass. Surfaces like PP, PE, powder coatings and plastics with plasticizer additives are more difficult because they may impair adhesion over time. The substrate's geometry has a crucial influence as well. For instance, stepped geometries and adhesive bonding around narrow radii should be avoided, and the bonding area should be designed to be as wide as possible. The cleanliness of the substrate affects the strength of the bond as well. Foreign substances such as dirt particles, greases or liquid films reduce the contact area. To achieve a reliable adhesive bond, three other parameters are important: contact pressure, time and ambient temperature. Contact pressure is dependent on the material, the component's geometry and on how fast a firm adhesive bond is required. As a rule, the higher the contact pressure, the faster a firm adhesive bond can be achieved. Pressure-sensitive adhesives require a certain amount of time to fully bond with the substrate surface. Adhesion continually increases during that time. How long that increase takes depends on the adhesive used and on the substrate. Generally speaking, adhesives with higher flowability achieve their final adhesion faster than less flowable ones. The ambient temperature affects the flow behavior of adhesives. At high temperatures, their flowability increases. That enhances the coating of the surface but reduces inner strength. At low temperatures, this effect is reversed. Adhesives should generally not be applied at temperatures below plus 10 degrees Celsius because the resulting contact with surfaces will not be optimal. Exceptions are adhesives that have been designed specifically for low temperature applications. In our next video, we're going to discuss materials for self-adhesive functional parts.